Hello everyone. We are back with another episode of Platform Connect webinar series. I am Ajinkya, your moderator for the show. For those joining us for the first time, here's what Platform Connect is all about. Getting to fully automated drone operations is a bit like figuring out a puzzle from start to finish. There are several small and large pieces that need to come together to make it happen. There is drone hardware, docks, payloads, sensors, UTM, detect and avoid parachutes, and several software components, each of which solves a critical puzzle piece that leads to the end solution. We are hosting this webinar series to talk about that. Before we get started, a few housekeeping rules. This session is being recorded, so you can revisit key parts of the session anytime you want. We have a Q&A session towards the end. Please feel free to write down any questions or thoughts you have in Q&A section. In today's session, we will focus on parachute recovery systems. Drone parachutes are crucial for extending operation beyond visual line of sight, as they provide an added layer of safety required by regulatory bodies. These parachutes ensure that drones can be safely recovered during system failures or emergencies, thereby meeting stringent safety requirements for BVLOS operations. This capability is essential for advancing the use of drones in more complex and varied missions across expansive areas. Today, we have our speakers, Josh and Havish. Josh is a co-founder and the CEO of AVSS. At AVSS, Josh is responsible for leading the long-term vision of the company and assisting the engineering team with building products that meet current and future regulatory needs. Josh is also a member of several drone industry-related groups, including several ASTM F38 committee, the tech lead for ASTM F3322 parachute recovery system standard, the British Standards Institute Advisory Group for Future Flight, and the Canadian ARPAS R&D Task Group. We also have Havish with us today. Havish is a part of the product management team at FlytBase. He is an avid off-roader, so he knows a thing or two about safety. With this, I pass on the stage to you, Josh.
Thank you very much. Appreciate everyone taking the time today to discuss parachute recovery systems and the integration with FlytBase. For those online, thank you for joining. Today's presentation is going to be very heavily regulatory based, so if you need to crack a beer or tip off your glass, go ahead. We'll get into the details and get into the weeds of things. If you do have questions and we're getting really too deep in and you're looking for clarity, throw some comments or questions into the comment section on the stream, and we'll try to answer your questions the best we can. So just to start off about AVSS. So AVSS is a Canadian company, started in 2017. We have the largest reseller network amongst the DJI distributors with more than 50 worldwide, as well as we're the only international company that is part of the DJI ecosystem that is an international parachute vendor. As well, we do work with various drone manufacturers integrating parachute recovery systems and specifically commercial drones and drone delivery companies. AVSS, again, as I said, many dealers across the world, primarily in markets where the product is required. And I think that's a very important point to start with parachute recovery systems is you buy it for regulatory compliance. Where we like the idea of trying to save your drone, making sure you don't the M300 doesn't break apart. But the reality is when you have a parachute deployment, you don't know what that ground's going to be. You don't know if you're going to land on the side potentially because you had a gust of wind knock the drone over. There's so many variables where the key thing about a parachute recovery system, it's about regulatory compliance and enabling you to do more. AVSS has also built out this large ecosystem of integrators such as FlytBase, but also working with drone manufacturers. We're the exclusive parachute vendor for Skydio, AV, Ascent, Nightingale. We also partners with DJI and part of their recent launch on the M3TD or M3D. We have various resellers worldwide. A lot of our end users are coming from outside of drone delivery is looking at construction, public safety, engineering work, telecom, and drone service providers. So why a PRS? Why do you buy a parachute recovery system? Big thing to understand is the role of regulatory and rulemaking. This is a quote from Drone Industry Insight, a market research firm out of Germany. They've been looking at the industry for several years now, and continues to be a theme of how rulemaking authorities are really preventing certain operations. And ultimately, it's in the guise of safety. And this is where we see that the parachute industry is really growing and becoming very important because of that enabling technology. Ultimately, a parachute's job is to reduce the pre-kinetic energy, how much that transfer of energy is coming towards you, as well as prevent laceration and injuries. And this is where we're seeing really the growth of the industry. And you're starting to see more and more countries outside of Canada, US, and Europe really adopt them. And some rules in some countries are very specific. You must have a parachute for certain types of operations, or it's more performance-based. So one thing in Canada we'll say is you can't have a single source of failure. You can't cause a severe injury greater than AIS level 3. So when you look at these rules, you're like, well, what the heck is a severe injury? Well, that's where we use AIS, which is the abbreviated injury scale. But then what's a level 3? What does that pre-kinetic look like? Well, if we use the FAA means of compliance for type cert, that's saying 128 foot-pound. So this is where the regulations might not explicitly say I need a parachute, but you're looking at keywords as severe injury, impact reduction, bystander safety, and these kind of items give you that performance metric where the parachute isn't the only way, but it's the easy way. And then a key thing about parachutes are, what are some key features? Not all parachutes are the same. When we started our company in 2017, a lot of people said, oh, parachutes are easy. Well, you go talk to enough people who do parachutes, they would argue otherwise. And one thing with the drone industry over the last 7 years is it's matured where now there's baseline of key features. So starting on the left corner here, what we call is an ATS. This is an automatic triggering system. This is basically making sure that if the drone were to fail, such as in the picture where this drone was in Japan handing out candy to kids, that it actually deploys the parachute. The next one is an FTS. FTS is a very critical component. It's a flight termination system. Some people think a flight termination system is to prevent the parachute lines from being entangled, when in reality, the main objective when we put on the aviation lens and we think of the regulator is to prevent lacerations. There are parachute systems out there that'll not include a flight termination system because they're going for a low cost, cheap solution. And I see in Europe actually quite often where people think that this is going to be compliant and this is going to work, but you're still going to cause laceration, as shown by an image on the right. This child was hit by a Phantom. So what happens when you're causing lacerations with a Mavic or an M30? Additionally, we do see some people are using flight termination systems that are after the fact, which require a lot of human factor and don't align with the industry standards or the expectations. Specifically on the Mavic, we see people putting on really low cost, cheap parachutes, and then they tell the operator, okay, if the parachute deploys, the drone's spinning out of control, the parachute's going to open, and I want you to do the CSC maneuver where you take the sticks and you put them downwards. Okay, that's an absolute disaster. But again, these are the key things that a lot of low-cost operators are just looking for that cheap solution. They want to make their profit and pull it off the table, where if you're building a professional organization, you're building an enterprise solution, you've got to start thinking of what's my product made of? Is it just a parachute, or does it have these features? And then a manual triggering device. So a manual triggering device, some people think is like, okay, a big red button. That's true. That could be one thing, but it doesn't have to be segregated completely from other operations. Now, for certain European rules, you do need segregation, but it still can be a deployment from a computer screen. It's about how that message is received and deployed, and that it's not tied into necessarily maybe the drone, depending on the country. And then finally, ASTM. ASTM is the international standard organization. It's the American Standard Testing and Methods organization. They have a committee called F38, which is about unmanned, uncrewed, drone, RPAS, whatever you want to call the word at this point for the industry. And the F3322 standard is the gold standard of parachute testing. This standard is a must-have for ops over people in the States when you're in category 2 and 3. In Canada, it's one means of compliance, not the only, but our preferred method. The other one is in Europe, it is used as an example for medium robustness, example 1. Again, there are some lesser, which I'll talk about later. But basically, ASTM is making sure that system has been tested, deployed 45 times, whereas some other means of compliance are like 2 flight tests. I don't know about you, but I feel more comfortable knowing that a parachute's deployed 45 times successfully over 2. And we make and sell them, but we also can have a faster path to market if we just take the cheaper standards, the lighter standards. But this is one of the things that we pride ourselves on when we launch a product full out, that we're going to have the ASTM standard. We may do some projects early on where we're rolling out with non-ASTM because we're trying to get some additional data, some pilot projects with new products. But ultimately, when we have a full launch and our products are going to our end users and dealers, we really want to focus on that standard. Next is talking about why a PRS and really going into our presentation today. So for the Federal Aviation Authority, having a PRS includes having a means of compliance before you even think of this. And this is for the ops over people rule, category 2 and 3. So this is not your type cert. This is not your category 1. This is the FAA's over people rule, category 2 and 3. And the first step is having a means of compliance. So AVSS was recently awarded a means of compliance first week of April from the FAA. And this means compliance, we submitted in September 2021. So, almost 3 years it took us to get all this approval. And then this means of compliance is comprised of key elements. So now that we have a means of compliance, whether it's a DJI drone, a Skydio drone, or another drone manufacturer, we can take them through our testing process to give them a flight over people. So that involves, like I said, ASTM F3322, that's the parachute standard. Then it involves 3389, the crash test dummy standard. And then we need to show how there's not going to be any laceration from exposed rotating parts and have a notification safety defect process. Once we have all these items, then we can make the declaration of compliance either for category 3, a transfer of less than 25 foot-pound or 33.9 joules. And that's something very important to highlight. It's not the pre-kinetic simple calculation, it's the transfer of energy, and I'll discuss about that later. And then category 2, which is 11 foot-pound, 14.9 joules. In Europe, EASA has come out with the general means of compliance for medium robustness, not for high. So you're -1 point on your GRC. And that includes 3 options. So when EASA is looking at this, they call it type 1, type 2, type 3. Type 2 is the parachute system. Type 3 is kind of combo. So on a type 2 system, it's your ASTM F3322 parachute standard. Again, very common. These regulators are looking for industry standards to kind of lead their way. Now, EASA has come out with what I think is a watered down 2-flight test, 30 ground activation. I'm not personally a fan of it. Again, as an owner of a parachute company, I don't like the idea of only having 2 flight tests. It's just not, it's not comforting. It's something that you will see companies argue that it's too expensive. They don't want to do it. It's something that industry standards play a role. And the ASTM standards, actually, the F3322 is one of the oldest standards being adopted in the industry. And this first version was published in 2018. I'm now the technical lead of the ASTM standard as of last summer. But when we started our company, we weren't at the table. And so we said, okay, this is the bar, let's meet it. And so this is something that really sets us apart on following these regulatory pieces. And then finally, with SORA M2 high robustness, trying to go for those -2 points, you're going to have an ASTM. Your medium robustness 2 flight tests aren't going to cut it. And then we're going to talk also about MOC 2511. This is the segregated FTS for enhanced containment, which has the optional reduced impact reduction system, which, again, when I talk about severity of injury, pre-kinetic energy, another word that reduce the impact reduction. So that's, again, EASA's kind of language on a parachute or another method. And then jumping into FAA. So as I said, the FAA awarded us a means of compliance on April 5th. This means of compliance is basically a key ingredients we need to demonstrate to them that a drone has been tested, validated, and will not kill somebody. Well, their comparison in reality is to space junk. Funny story, when they looked at pre-kinetic energy levels, they went back to existing research, I think from like the 80s, and they were looking at figures from space junk and basically said, okay, this 25 foot-pound or 11 foot-pound pre-transfer kinetic energy is what we're going to set as metrics. And this is what the means of compliance is. And so we're the first parachute recovery system company in the world to have this. There is one other means of compliance. It's a university. The difference with us when we're working with drone manufacturers, we're doing all the work for them. We're doing the parachute testing, the crash test dummy testing, the reporting, and we're able to kind of collaborate that. Now we work with a partner on our crash test dummy testing, but ultimately we're able to take our clients and bring them through this by having a complete solution with our partners. And then again, going into a little bit of the weeds, category 2 and 3. As I said, it's all about for the FAA that it will not cause injury to a human being that is greater to or higher severity than the certain amount of kinetic energy. Again, 11 foot-pound, 25 foot-pound. That process requires that means of compliance, which the FAA has to approve. you can't just go and say, hey, here's my means of compliance, I did it. It's like, no, the FAA has to review it and approve. And this is where, again, for AVSS, we made this big investment and worked with our partners to get this through, is because we saw this as a way to help our clients get to market, specifically drone manufacturers. And ultimately, the end users don't really need to know about all these details. What they really care about in the US is this DOC process, this declaration of compliance. This declaration of compliance is when they go on a list on the FAA's website and the drone's approved. We have a similar system in Canada, and EASA has adopted something similar. And this is basically a checklist in which, okay, this drone's good, I can do this type of mission. And then there's some other kind of nuanced details about safety defects. And so US customers will have to register through a specific portal so that if there is, firmware updates or some sort of issue with the drone, we can contact them. And then when the rule was first created, remote identification wasn't mandated yet. So they threw in this remote ID for open air assemblies. Now with the FAA's rules with remote ID, everyone's going to need it. So it's not as relevant. And then a key thing is to understand about operational restrictions. Operational restrictions are something that for category 2, you don't really have any because your kinetic energy is so low. So your severity of injury is low. So they're allowing for higher probability and having those kind of flights over people. But for category 3, you need to be within a closed or restricted access site to have hover flight, but you can just do transient flight. So again, there's some nuance there. And then just kind of quickly going over the MOC's process. So going through what is 3322, 3389. And so that's that parachute standard I said. So we did it on the M300, for example, in April 2021. This testing demonstrated that the system works, and we performed the testing that we actually cover the M350 as well. And then we have to go into crash test dummy testing. So crash test dummy testing is referenced as ATD, anthropomorphic testing device. This is what you see in the airbag. So in ATD testing, we have to compare this rigid object on the left-hand side here. And we have to compare what type of injuries are being created to the neck, to the head. And then we take the drone and we do a similar flight test, same rigging system. And this is something we're doing with a partner of ours. And this type of testing, what we end up resulting is comparing this rigid object to the M300 in this case. And if the injuries are less than the rigid object for either category 2 and 3, that is how you have compliance. This for drone manufacturers, this does require drones that are in physical perfect condition, but you don't need to have all the electronics working. You can have representative mass. And the key thing is looking at how that transfer of energy is coming through. So this is the same process you have to do for every drone. So we've already done this testing on the M300, on the M200, the M30, the M3E, and we have a lot of insight into what drones are going to qualify and what ones are not. And then from that, you have the FAA's process of category 2 versus category 3. This is a unique to the FAA where they have these two kind of categories. And category 2, you're allowed to sustain over people who are not involved in the mission. Whereas category 3, you can do transient flight over people, so you can't stop moving, who aren't a part of the mission. Or if you want to hover, you need to have this restricted access site. So that could be a movie set where everything's fenced off. It could be a mine, an industrial site. But ultimately, in category 3, these customers or these end users are going to need to know that there's a way that somebody has kind of acknowledged that there's going to be a drone over flight. So in the actual rule, the FAA says, yeah, you can get people to sign waivers, but that's not necessarily needed. You could have signs, but this is where the US market and its litigious side is something that you probably want to have waivers. You want people to sign off if they're not involved. But again, it's about notification, so large signs and communication. And now jumping into EASA's MOC 2511 and 2512. So EASA's means of compliance for 2511 relates to enhanced containment that has an element of a parachute, but the key thing is about the air risk. Whereas MOC 2512 is more about M2 mitigation and the ground risk. So starting with 2512, the M2 mitigation. So those that are familiar with SORA, the specific operational risk assessment, an M2 mitigation is a reduction of the ground risk. And what they're looking at is reducing the integrity ground risk reduction targets to 90%. And by accomplishing that, you have 3 options. So type 1 is about reducing the critical area, so the operational. And then type 2 is where we'll really focus on, is about the parachute system, reducing the kinetic energy and the lethality. So making sure that causing a fatality is reduced. And then type 3 is a combination of using type 1 and type 2. So any M2 mitigation needs to provide evidence of reducing the effects of ground impact. So that's like your kinetic energy, that's your descent rate, as well as being able to be reliable. This is where we argue your 2 flight test 30 ground activation is kind of insufficient for reliability, but this is where ASTM 45 tests are really a benchmark, and it does not increase risk. And this is where, going back to the discussion on, like, you'll see really low cost, cheap parachutes on the Mavic, and then they'll tell you to do the CSC maneuver. And it's like, wait, how am I supposed to be able to react to a drone falling out of the sky, have the parachute deploy, get my senses together, and then do the CSC maneuver? It's like the human factor side. It's just sensory overload. There's too much expectation. And this is where your full system, having everything automated, where parachute deploys, flight termination is enacted, is really the key ingredients in our view. And also with type 2 means, basically, you have 4 ways you can demonstrate it. Going back to some of the language we've already discussed, 3389. So that's that crash dummy testing. Really, for any drones above a kilogram, even then, you're probably not going to get your kinetic energy unless it's completely made out of foam, like the SenseFly EV. And this is where the AIS level 3. So that is where, if we use the FAA means of compliance and look at what is that AIS level 3, that's the 128 foot-pound, approximately 173 joules. Oh, wait, that's exactly what EASA tells us with the maximum impact energy. And that's a key point. It's the impact energy. So that's a baseline calculation where a transfer of energy is where we're looking at from the ATD crash test dummy testing on how those materials. So a drone that weighs 3 kilograms made out of foam versus a drone that weighs 3 kilograms made out of metal is going to have different transfer of energy properties. And then ultimately, again, as I talked about, how do you comply with this type 2 means of compliance? Again, our recommendation, ASTM. As well, though, you can do the 2 flight 30 ground activations. And there's some more nuance there about the size of it and how you're supposed to tie in on type 3 using the critical area as well. So there's a couple ways to do compliance. When I think we look at DJI products, like, if they're not ASTM F3322, I'm questioning them. It's like, the market's big enough, there's enough units, we know how many drones are going to be out there. And if you can't meet that compliance, it's like, are you just trying to make a quick dollar, from my perspective? Now, there are some larger aircrafts that, $250,000, very specific use cases where the economics might not make sense, and you do your own internal testing. But again, for DJI products specifically, I really question those companies. And then let's talk about MOC 2511. This one's big in certain countries where there's more air risk. Switzerland, we see it in Ireland a lot. And then basically, the purpose of MOC 2511 is to make sure that in an emergency, that the drone stays within the ground risk buffer and it doesn't have a flyaway. So again, it's not really about having a parachute per se, but if we look at the Irish Aviation's advisory from 2022, they talk about why a parachute's included is more of the human factor. If you're flying a $50,000 M300 with all the LiDAR sensors and fully kitted, what you're looking at is a situation where a pilot might be kind of hesitant to press the red button because, hey, I don't want my system just falling out of the sky. And this is where the Irish actually had provided suggestions on including a parachute from a human factor side of, maybe they'll be more enticed to actually click the button when they hope that the drone comes down at 4 meters per second instead of 20, 30. And so part of the MOC 2511 is there's a checklist to ensure FTS segregation. And I think that's the big thing that a lot of people are confused about. Why is there 2 models? So in Canada, the US, and in some European use cases, you don't need the segregated FTS in a lot of parts of the world. But for Europe, for enhanced containment, they wanted a segregated FTS. So there's a few ways to do segregated FTS. When you're dealing with a DJI product, there's usually you can do surgery on the drone, or you can try to do a retrofit hardware module between the battery and the drone. In this photo here, the arrow is pointing at this yellow module. So that sits between the TB50 or TB55 battery and the M210 power source, and basically acts as a middleman. Our system detects failures and shuts off the power. And this is a way to ensure segregation. Whereas if you look at like the Canadian US market, we're using the PSDK, and the PSDK is a way to send a kill command to the motors and shut them down. So there's 2 ways, but ultimately for 2511, we want that segregation. And then another example on our M300 product or M350, we have another segregated FTS option. And the thing that's nice with the M300 is we'll do both. We have the PSDK and the segregated, so we have a dual reduction of ways. And again, the FTS needs to be segregated from any elements that if there's such a failure that the system will still work, unless that failure automatically leads into the drone crashing. So the power source is an appropriate one. And then this is an example of a recent parachute deployment from our M3D test. This is from Hydro Snow and showing the capabilities of the system coming down for the dock kit. And then handing it over to Havish to kind of discuss more about the integration with the AVSS solution, the Dock 2 operations, and how the systems perform in concert.
So, Josh, thanks a lot for all the details you gave about the AVSS PRS system. First of all, congratulations on getting the MOC from FAA. Like you said, it took you 3 years, but yeah, you're there. So, I mean, I don't know how difficult that was, but I do know it probably wasn't easy. So,
yeah, when I started, I didn't have gray hair.
And Josh, not only congratulations for that, but also congratulations for being the first parachute company to get that.
Thank you. Yeah, we appreciate that.
So clearly there was a lot of research, there was a lot of regulations handling, risk mitigation, damage, even actually testing, right? So like you said, just 45, it had to be triggered 45 times for the FAA means of compliance. So I just had I think a natural question, like how do you recharge the system once it triggers or deploys?
So how do we recharge? Do you mean how do we like replace the system?
Yeah.
Yeah, so depending on which parachute is on the M300, we have pods we just replace. For the M3DT, we just repack. We put in a new charge and repack it. And the one thing to highlight with the ASTM standard is the end user isn't supposed to repack. Now, there is language where a parachute company can train people. I take that in I think a different view than some of my competitors, where some of my competitors will say, well, here's a video online, go do it, or here's a manual. It's like, we don't do that internally. That's not how we make our products. And if you suggest to your end users that that's how you can manufacture your products, that's very sketchy, I guess, concerning to me, where how much training and at our company, we can train drone manufacturers or a high volume dealer for repack, but there's a whole program and requirement, and that's not something you're going to do with watching one video. So per the ASTM standard, we would be doing the repack unless we had a repack depot in a local area where we've trained those people. And the thing with parachute packing is, I think it's really important, is if you're not doing it on a regular basis, you will make sense. I don't know if anyone is here a Boy Scout or something similar where you have to learn to tie knots. If you're not up to date on how to tie those specific knots, like you're going to make a mistake. And the parachute's the one thing, like if you screw up the PCB, you don't connect it, the cable, you get these feedback mechanisms. But with fabric, like there's no feedback there. And yes, you could put some sensors, I'm sure, in the fabric and have a patent and have all that cool stuff. But ultimately, a practical side of it is you have no feedback. So if you're not properly trained and up to date on your training, packing shoots every day, I'm very hesitant on that idea. So yeah, I hope that answers your question.
Yeah, definitely. So once I took a paragliding course, and in the after the main paragliders, there's a reserve chute, and it's the similar rules on the reserve chute. Not anybody can pack them. That needs to be somebody who's well trained to do it properly, so that when you pull it, it actually deploys. So I completely understand your point about it being a trained person who is only allowed to do this. Makes sense.
Yeah, imagine jumping out of a plane with a parachute you packed for the first time. If you're willing to take that risk, you're in a different level of risk profile than I am accustomed to.
Yeah, probably won't get FAA certified.
No, probably not.
Right. So yeah. So as clearly mentioned, obviously for BVLOS, parachutes are really important. It's really good to see that so many of the common drones that DJI sells, they're all supported, they're well tested, and anybody who is looking for getting regulations and getting started with their drone autonomy, yeah, they're good to go. So yep. So all the hardware is there of the drone, the parachute, and whatnot. So now let us look into what does a drone autonomy software add to this solution. Like, how does it really help the customers going forwards, right? So there are a lot of key components which contribute to building a true autonomous drone system. So when you mention autonomy, obviously now if the autonomous system has to do a lot of things, it also needs to do it safely, right? So that is why in this picture you see right now there are so many things that are again safety related. So there are things like detect and avoid sensor integration, so that you know that your airspace is safe. There are parachute recovery systems, there remote ID, there's weather reporting, there's ADSB receivers. So all of these are different components that need to feed in to an automated drone system so that they can perform at the same safety level or even more than how much maybe a person on the ground with the drone flying it with his own RC probably could, right? So when you bring all of these pieces and everything together, then that is what we offer here at FlytBase, which is the platform which is able to bring all of these pieces together and provide one single solution, which along with the hardware gives you a remote autonomous software to do scaled drone operations. So moving on. Right. So yeah, like I said, that's where the FlytBase and AVSS integration comes. Now let us see how we can kind of bring the AVSS technology onto a Dock 2. So in the video, we can see that a Dock 2 is operated through the FlytBase dashboard. It's preparing to take off, and right on the bottom of it, right beyond beside the RTDS, which is the return to docking station, there's a parachute button. So this parachute button is something that people can trigger remotely if they see that the drone is going outside the safety operational area or anything else that has caused an alarm to them. And because the FlytBase platform is an autonomous platform, it is also a remote platform. They can actually trigger this from anywhere in the world, right? So along with that ability, what are some common steps that anybody in the drone safety process would take? So one of the most obvious thing is a checklist, a pre-flight checklist. So in the pre-flight checklist, you would check if, let us say, the drone's geofences, the no-fly zones, they're synced, if the battery is good enough, like it's fully charged, if you have integrations with any UTM, if your parachute, in this case, is ready to fly or not. So if your parachute is ready, that means it's reporting it has no errors internally. It says everything is okay. The internal batteries, if it has, they're charged and everything, then you know that you can fly. So let us say, like Josh said, there are some of these systems, they have a harness and they have a pod. If the harness is there, but the pod isn't mounted, which actually carries the parachute, then you may get an error like this, which says that the parachute is disabled. The warning is like the device is unmounted. And as an autonomous system, we would be offering features where if there are any issues with the things that need to be checked in the checklist, the drone would not be allowed to fly autonomously. So pre-flight checks, they're the first step in flight safety before you fly. Then moving on, we have the parachute deployment kind of a representation. Now we are bringing all of these features to our dashboard. They are all in our near roadmap. We're kind of just waiting for Josh and his team to release the parachute, and we'll just integrate it, and then we'll have it available across the world, in Europe, in the US, whatnot, right? So this is how it's going to look like. We're going to have the parachute button to trigger, and then there's going to be confirmation so that an accidental press on that button does not lead to a deployment. So there's the cancel button, and then there's a deploy parachute. Now, if you were to actually deploy the parachute, then the next, I think we'll see, right? So what happens after the parachute is deployed? So we may think that the journey just ends there, but in a remote operating platform where there are again there could be a lot of users, like this could be an organization, right? And in that organization, there are different pilots. The first thing we need to do is bring the attention of whoever is online and on the dashboard to the particular drone where this incident has occurred. And one of those ways that we bring their attention is this through this alerting system. You guys, obviously, PPT like this is just a presentation, so you can't hear it, but in reality, there is going to be a sound which is going to be coming out to draw the attention of the user to the dashboard. We're going to be highlighting the location of the drone. If the parachute has its own GPS, like as required for MOC 2511, then we would also show the location of the parachute's GPS as displayed. And there would be an alert in the alert system. There would be the beeping of the dashboard and the raising alerts. That's not going to go away until one of the users who is online acknowledges that, okay, I have seen this issue and I'm going to take the next steps. And this acknowledgement about who is responding to this problem would be recorded so that later on in kind of a post-flight analysis, like an aircraft investigation, then you can check that, oh, who was online, who took control of the situation and kind of retrieved the drone or was aware of it, right? Then this is the post deployment. Now, what would be the next step for anyone once the drone has crashed? It would be to obviously go and recover the drone. Obviously, ensure that if there are any people hurt, any critical infrastructure damage, let the relevant authorities know. So for that, on our dashboard on the left, you can see that there is some information about the parachute, like if it's healthy, what is the battery percentage, the location of the parachute, and then on the right, like on the main map, the first red dot is where the parachute was deployed, and the rest of the path is of the drone, where it, like if it was pretty windy, then even after the parachute is deployed, the drone would move a certain distance. So that is highlighted in red, so you guys can see that. Again, the drone is blinking, drawing the attention of the user to the map. And on the left, there is a button called as view on map inside the parachute box. If you would press it, then I think then we would open a Google Map link, and that Google Map link would help you get to that place where the accident occurred through your phone. It will open on your phone, so you can drive your car from point A to point B to get to that place and then retrieve your drone. So ease of access to help you recover the drone in any such situation, right? So yeah, now let us just look at one more scenario. Let us say your drone is equipped, you're operating in a safe area, and it is scheduled. So it is doing autonomous flights, right? So it had to do a flight at 1 a.m., then it had to do another flight at 2 a.m., 3 a.m., and whatnot. It is just continuously doing the flights, collecting data for you, keeping your perimeter secure. If such a situation happens where a parachute is deployed, then how would you draw the attention of a person who is not on the dashboard? So for that, we have things like operational notifications, where you would immediately get an email. You would also get an SMS in case you're in an internet denied environment, which will tell you about which drone is facing this issue and that the parachute has deployed. And now now they need to get on the dashboard, find the location, like I showed in the like it was showed in the previous slide, and then get to the place to recover the drone. Then the last thing, which is obviously if such an event occurs, people would like to understand what happened in it. When did the drone deploy the parachute? Where did it drift after the parachute was deployed? And it's basically a report. For that, we have features of flight logs. So in it, you would be able to see that there was an RTK unhealthy incident or whatever that happened, which led to some kind of a sensor failure in the drone, and the drone went into a free fall. As it went into a free fall, the parachute detected the free fall, it deployed, and then what was the last location of the drone in such a situation. This flight log would be downloadable. It's like it can be played back. There's an option to play back this whole incident as it happened, as the drone flew along all of these locations. And this is one of the best ways to understand this situation, so that going forwards, action can be taken to mitigate something like this from happening again. So along with the parachute, what other components are there in safety, right? So for that, the way we bring in safety and onto our dashboard is through Flinks, which is the FlytBase links. There are different devices, there are different services that can be integrated onto FlytBase through Flinks, right? So there are three different types of Flinks mainly. The Flinks are in three different categories. They're safety, autonomy, and efficiency. So in the safety category, you have detect and avoid systems, you have UTMs, you have parachutes. So some of these are devices, some of these are other softwares like Cassagy or Flight Radar. So bringing in the data from these kind of products onto our dashboard, overlaid it so that the user can see about what exactly is going on in its airspace, helps with safety and securing the drone in case of a parachute deployment. Autonomy is when you have a scheduled mission which is going on, like I said, in 1 a.m., 2 a.m., 3 a.m., and all of that. And the last one is efficiency, where we have data processing apps like Drone Deploy, which can process the data collected in that mission and then send it over to be post-processed to be stretched into a 2D map or a 3D model. Yeah. So That's about it with respect to how can flight autonomy help. Software like ours, which is a remote flight autonomy software, can help along with great hardware like the parachute and the DJI drones. If anyone has any questions, we can go to that.
Yes. So yeah, thanks a lot, Avish, for that session on or presentation on how software or what role software plays in integration with the parachute as well as other systems when you're flying autonomous drones. So that was really insightful. And now we have gotten a lot of questions during the presentation. So I'll just go through the questions one by one, and the audience, please feel free to drop in your questions anytime if you have any. So again, this question, I think this is for you, Josh. It is from Taylor. Is asking, what are the regulations in Canada for using the Dock 2 system remotely on a site with workers and traffic?
So when you're going to be using the Dock 2, right now the rules are you need a visual observer. So the visual observer is an interesting one where you would need to do training and you need to have an RPIC on site. So that's a situation where you can have the automated flights going, but just to leave it and not have your RPIC and your VO trained would be a problem, from my understanding. Now, in Canada, starting in April 1st, 2025, so less than a year, our BVLOS rules are supposed to be implemented. Last year, we did the announcement. We did the NPRM process, what we call Gazette 2 or Gazette 1, where they go and they get feedback. And from my understanding is they're still on pace. And in that case, we'll be able to do low-risk BVLOS. Now, low-risk BVLOS is based on a population density, so it depends where this construction site's at. Is it downtown Calgary or is it, in rural Saskatchewan? So there's going to be some nuances there. So I think with the Dock 2, we're going to see is really getting it set up, having somebody who can take control, who has the VO on site. And then I think that the real path forward, if you want to get ahead, is get some operational data and then apply for an SFOC. I think Transport Canada stated in their low-risk BVLOS rules where, if you're in a rural area, they're going to be more inclined, and they really want to focus on the higher-risk BVLOS. And just the reason why we're saying this strategy in Canada specific is that's what we're doing. So my colleague Mariah is getting one of the Dock 2s at her house. We're going to be running operations for over the next year in a very intense climate that ranges from -20 Celsius to +30 Celsius, as well. We're 10 kilometers from the Atlantic Ocean. So we're really going to be in a really interesting environment with changing conditions in New Brunswick. And this type of data is what we'll use after a few months to submit for an SFOC. So that's the strategy we're taking. So not a very direct answer saying do X, Y, but I think there's some room for having someone on site, being the RPIC, moving to an SFOC, and when the new rules come, hopefully aligning with those.
Right. Thanks, Josh, for sharing that. And again, there's a huge amount of data that needs to be collected and stored, and that is where, again, with the help of the software systems or flight management platforms, like Havish mentioned earlier, a detailed incident management or incident logging system can help because it has detailed data points of each and every flight that was conducted. Yeah. Another question we have from Matthias. Matthias is asking, regarding the checklist before, do you need to manually tick off every box before an autonomous flight, even the scheduled ones? So this question is for Havish.
Right. So the checklist can be automated too. The minimum thresholds for each of the things in the checklist can be preset. And when the time comes for the drone to fly, if any of those things are not met, then the drone mission won't be launched. So, like for example, let us say the parachute is currently not healthy, then we can have the setting is there so that if let us say the parachute is not healthy, the scheduled missions would not launch. So that would maintain the safety. That's a good question. Thank you.
Oh, you're muted.
Thanks for that, George. So yeah, we have a question from George from Greece, one of our friends and partners. George is asking how much height is needed to open the parachute for it to be reliable.
Yeah, so that's an interesting one. So in my opinion, you're going to see, this is me forecasting the future, hopefully better than the weatherman or weather person, is the MOC 2512 parachutes that only use 2 flight test 30 ground activations. I think you're going to see this weird range of minimum deployment altitude is what we refer to at ASTM, where have they actually gotten enough sufficient data to demonstrate what the MDA is, minimum deployment altitude. And with ASTM, when you do these 45 tests, about 35 are relevant for your minimum deployment altitude calculation. And in this testing, you'll get a range. And ultimately, you have to choose your outlier. So in normal ASTM data point like descent rate, kinetic energy, you're using averages. But for your minimum deployment altitude, the standard has called out using an outlier. So on the M300, our system works at 18 meters, we've shown. But if you have one bad test and you have some oscillation where the parachute's swinging back and forth, it doesn't reach something called steady state. And the steady state is when we determine. And so for ASTM parachutes, they might be a little bit higher, or depending on if someone cherry picks the day and in which they do their testing. We've seen that in the past with parachute companies will just not go day after day. They cherry pick the perfect weather, make sure that they don't get those winds. And so their specs look better. And that's kind of some of the nuance of the parachute industry of how they kind of game the testing, where the spirit of the test is just go do it, 3 days in a row and get it all done. Now things happen and you need to have rain days and damage and things, but ultimately the MDA for the M3DT, you're going to see a range probably 20 to 30 meters based off the ASTM standard. Again, this is something that I really stress to end users or dealers. When you're looking at these other parachutes, these are the questions that you should be asking us. What is the MDA, but how did you reach that calculation? What are your data sets? Where are your points? How many tests did you do to reach that? Because it seems like in the industry, these questions, it's what is the MDA? But no one asks for the background math. And yes, we're not in high school. We need to show our teacher all the math, all the work we actually did. But really these are the key questions that regulators eventually ask. And your insurance company and the lawyers, especially from the States, are going to ask is, you chose this system. Why did you choose it? Okay, this was the industry standard. And then, okay, you're going to be a little bit an easier piece. Oh, you chose your own means of compliance? Okay, well, what did you do for those means of compliance? How did you get those calculations? What was data saturation? And this is why from our company standpoint, again, I'm kind of ranting here on this, is industry standards are great because they give you that clear path that there's a consensus around. So kind of a long answer, parachute for the M3DT, 20 to 30 meters. Our official ASTM testing will be done this month. We'll be able to announce what those actual key parameters are. But we're testing at 15 meters, 10 meters right now.
Yep. Thanks, Josh. Thanks for that detailed answer. And now the audience know what kind of questions or what questions exactly to ask while choosing the right parachute for their drone and for their operations.
Yeah, I'm thinking we now have some spam for LinkedIn. We can do a Q&A on what's the MDA and how did you reach it? What's the kinetic energy? What's the angle? I'm sure there's some FlytBase online content we now can create.
Certainly. Yeah, so there are some words for appreciation for AVSS. Guillaume is saying that they use the M300 PRS daily for almost 3 years, and they feel safe, confident, and legal with it. So that's thanks for sharing that, Guillaume. Yeah, we have another question. This is from Guy. It's from Belgium, and this one's again for you, Josh. So Guy is asking, is there a solution coming for the DJI M30T and the European problem that the maximum takeoff weight was set to 3.9 kg? Weight of the drone, including batteries, is about 3.7 kgs, max takeoff weight for C2 certification. And in Europe, EU, 3.9 kgs. So they only have 228 grams to add to the M30T.
Yeah, so to actually drill into that, the original C2 version, yeah, you only had 228 grams. And this is something we actually discussed with DJI, and you'll notice in their user manual, there's now a classification where you can go to 4097. So you actually have, we call it 289 because it's 3,770 grams plus minus 10. So we just use 3,780 grams. Again, we're a safety company. Add that safety factor if there could be variable. And so you really have 289 grams. So you will get an MOC 2512 parachute under the weight class. And this is something we're actually running a DFR program here this month with partners of ours in Canada on the M30T and on the M3D. So both dock versions. For enhanced containment, you will exceed max takeoff weight. And this is an interesting one because that means you're in the specific category. currently with the EASA rules, you are allowed to exceed the maximum takeoff weight of the drone if you can self-declare as the modifier, such as us, and we can go above that weight. Now, that's great, and there's kind of limitations there, and this is one thing that we've been trying to nail down with the different regulators is those interpretations, because if you wanted enhanced containment for Dock 1 for the M30T, you're going to exceed the weights, and we have a solution we can provide. There are some solutions on the market. Some are really heavy, above 600 grams, I believe, but for the enhanced containment version, you're going to be above the 289. You're going to be probably closer to around 400, if not a little bit more. Now, could the M30 take that? In our testing, it can, but that's the piece that it's really country specific. Now, for the US market, the Canadian market, the non-enhanced containment versions, you'll be within the weight, so you're totally fine for those weight classes, but you won't be able to leverage that C2.
Yeah. Thanks, Josh. I hope that answers your question. Next question is again from Matthias. This is for both Havish and Josh. I'll take the first part, which I think can be answered by Havish. So Matthias asks, combining both FlytBase and AVSS with the Dock 2, is the system able to theoretically operate autonomously for several months without human intervention?
Yeah, that's a very, very interesting question. Yeah, unless there are no hardware failures and everything has been configured properly, it's a safe area where we are operating, all the regulations and everything is met, then we don't see why not. Both the hardware, which is the drone, the AVSS system, and the software are enough robust, enough reliant. They have been tested thoroughly and extensively. So it's unlikely that as long as, yeah, they can. I don't think there would be any hiccups to that.
Yeah. And again, second part of that question is the AVSS system as a whole, can the user install it themselves?
Yeah, it's what does it take? Plugging into the PSDK and mounting to backup straps. If I can do it, you can do it. That's the mantra.
Perfect. Another question, again, it's for you, Josh. Oswaldo asks, it says, is AVSS willing to provide a course to teach trained dealers to replace the parachute in the near future?
So we've had these discussions historically, specifically on the M300. We won't train people because there's just a little bit few more steps. With the new tube designs on the M3D, the M30, and the M3E, it is an easier pack in which we feel comfortable training people based on our experience training other engineers in the office very quickly and going through those processes. It's something that we're not committing to today because when we launch the products this summer, we have 12 months to figure it out and to decide how we're going to approach that. We may choose a repack center in Europe and America from one of the dealers that has done high volume. If you're a dealer only doing 1 or 2 units a month, we probably would not feel comfortable having that training because your volume of units means you're not going to be kept up to date on training. Like I said, it's like learning to tie knots. If you're not doing it every other day, you can get out of rhythm very quickly. And again, it's something that you might not know for 12 months until that drone fails, that you find out you made a mistake and how many mistakes did you make. So we will be training someone potentially, but it's something at this point, it's still under evaluation. And basically, we need to make sure we pick a dealer that one has the adequate space. A parachute table is a little bit of a decent size, and we need to make sure that dealers that we work with on training that they're doing sufficient volume to justify it. And that's just at the end of the day for us, it's feeling better for the end user to know that they're covered, because if you pack the parachute wrong, they'll still somehow will get blamed for something, and we're going to be the ones certifying it. So we want to make sure that we take that very cautiously. So the answer today is maybe, but we're going to be very selective on how we did make that final decision.
Yep. Thanks, Josh. Another question we have is from Taylor again. AVSS parachute on the M300, are we able to add another payload lidar to drone that utilizes the OSDK port? Can you use both the payload and the parachute through a separate OSDK port?
I know that you can plug the payloads in on the bottom for the cameras. So there's that option. If you're looking to use the one PSDK port that we're plugged in, We have split it before for an onboard computer. We don't offer that as a standard kit. If someone wanted to make an argument to do that, we could look at it. There'd be probably some costs associated. But the one thing is, I don't think we have a picture here of the AVSS parachute on the M300. But one thing is, if you go on our website and you look, you'll see that our parachute isn't mounted on top of the 4 screws where other parachute companies are using. We actually designed a bracket that could make the parachute sit back. And that was designed specifically to keep that top mount payload port open. And so, some people are doing bridge inspections and they have the H20 on the top, and that's where people are using it. So we've seen people use that on top. But if you have it and you're coming with like, hey, I want to add onboard compute and do some edge computing and control the drone more, well, we'd have to split it for the PSDK. And we've worked with FlytBase on a solution similar to this in the past. It's not something that we advertise, nor do we actively sell, but it's something that if someone came with a good business argument on, hey, I really want this, and this is how many units, and these are the costs of NRE that I'm willing to pay, there could be an argument.
Got it. Thanks a lot, Josh. Another question we have is, again, Dock 2 is now commercially available. So what are the timelines on the PRS system for the M3D? Are they already in production and people can get their units soon?
Yeah, so we start accepting pre-orders from our dealers. So the way it's going to work is we're finalizing all our testing this month. Then we've already started working on supply chain items, things coming in. And so basically we'll be shipping the first batch at the end of June, the second batch in July, and then as well during July. Sorry, just to preface, the first batch that's going out is going to be an ASTM version. It's going to be compliant with the FAA's rules, the ATD rules. It will not have the enhanced containment at the start. So the first version, MOC 2512 in Europe. It also will be the FAA Cat 2 or 3. You'll have the Transport Canada over people and the SOAR M2 mitigation. That version will be starting to ship first batch in June, second batch in July. And then our first batch of enhanced containment, specifically for the European market, the 2511, that'll be in later July. That'll be shipping out as well. So the simple version first, and then the more enhanced containment version second.
Perfect. Thanks for sharing that, Josh. It is very helpful for the audience. If you can just share your coordinates, where if someone wants to reach out to you, where can they reach out, or what platform do you prefer?
Yeah, I'll put that in the comment section. You can reach out directly to me. I'll just put my email. I'll put my colleague's email address, Mariah. She works with most of the DJI dealers. She's our VP of Ops. So I just put her email in there, and then, it won't let me post this. It says, at AVSS.
Let me do that.
See if that works. Nope, I'm not able to post, but FlytBase can post Mariah's email address or my email address in the follow-up for contacting us, or you can go to the AVSS website, avss.co, and put content there.
Yeah, I'll just do that for you. Yeah, it's in the chat. So if anybody wants to pre-order one of the units for their Dock 2 or any other drones, please reach out to the AVSS team. And you have any technical questions or anything about FlytBase, you can reach out to Havish or me via our website, or again, other channels such as LinkedIn and so on. So yes, I think we are over time. So thanks a lot, everyone, for joining in today. It was a great and informative session on how having a parachute system on a drone is critical and helps in safe operations. So thank you, everyone, for your time. Josh, any closing thoughts?
No, I think thank you, everyone, for joining. If you have more questions, let us know. I think over the next 3 years, you're going to see a lot of expansion from line of sight to BVLOS. And I think with FlytBase and the AVSS solution, you're in a good spot. And if you have questions on the integration or on any of the work, please reach out.
Yeah. Havish, any closing thoughts from your end?
No, I completely agree with Josh. I'm excited for the future.
Great. So thank you, everyone. Thank you for joining in today, and stay tuned for the next episode of Platform Connect. Have a great day.
Thank you, guys.